The objective of this video is to show you how to find trig ratios of the three basic trig functions: sine, cosine, and tangent. Given that you have a right triangle, you should be able to look at an angle and find out what ratio you are given for the particular trig ratio or trig function. We use what's called SOHCAHTOA to help us remember the ratios that go with each trig function. S stands for sine, C stands for cosine, T stands for tangent. Now SOHCA and TOA, neither of those are actually trig functions. This is just a nice way to help you remember what the ratios are. The three sides of a triangle based on a given angle are opposite, adjacent, and hypotenuse. So that's obviously going to be opposite. It's going to be the O. Adjacent is going to be the A. And hypotenuse is going to be the H. So these 9 letters help you remember what the ratios are based on just giving a single letter. Okay. In order to be able to give a ratio, though, you need to be able to label opposite, adjacent, hypotenuse. Opposite is exactly as it says. It's across from the angle. Imagine standing at a corner of a room and going the opposite corner. That's exactly what I'm trying to say here with the triangle. It's across the triangle. The hypotenuse you've talked about before with Pythagorean theorem. It's always across from the right angle. That never changes. Adjacent is the side length next to the angle. Instead of being opposite, the one that's across is the opposite. The one that's next to is the adjacent side length. So this first example, number 4, they ask for sine of x. X is right here. Opposite x is 21. Adjacent to x is 20. And hypotenuse is going to be 29. Now, sine starts with an S. If you look up here to SOHCAHTOA, S goes to OH, meaning it's opposite over hypotenuse. So, your opposite side length is 21. Your hypotenuse is 29. And that is your ratio. The reason why we've set up these ratios is to help set up equations, because after you set up an equation, you can solve for a missing angle or a missing side length. But the main skill here is setting up that equation. Sine of the angle x is equal to 21 over 29, because 21 is your opposite, 29 is your hypotenuse. Let's change gears here for the next one. It says cosine of z. Z is down here. Therefore, 20 is now opposite for z. Adjacent for z is going to be 21. See how that flipped for x, now over to z. Hypotenuse is still the same. No matter if I choose x or z, the hypotenuse doesn't move. So for cosine, that starts with a C. Go to our SOHCAHTOA 9-letter mnemonic. Cosine goes to AH. That's adjacent over hypotenuse. So that means cosine of z is going to be equal to adjacent, which is 21 on the picture, over 29. You can also draw the comparison here. The sine of one of the angles is the cosine of the other angle. That's a relationship that's fundamental to trigonometry. Tangent of z. Let's change the colors up here. So we can use the same z side length labels. Tangent starts with a T. Tangent goes to OA. That's opposite over adjacent. Opposite over adjacent. So that's going to be, for z, opposite is 20. Adjacent is 21. Now, sometimes you can simplify these fractions and sometimes you can't. In this case, you can't simplify any of these, so they have to stay as is. But if, for example, you had the fraction 6 over 8 in your triangle, you are expected to write that as 3/4 and simplify it. So these two numbers are equivalent numbers, just this one's more simplified. And that's how you find a trig ratio for a trig function in a right triangle. First thing I would do is label the lengths, side lengths, opposite adjacent hypotenuse. You know where to put them within the ratio. Obviously, you're going to need the SOHCAHTOA saying to help you remember. But at a certain point, you're going to be doing it so much that you won't need to have it at all times. But it is good to write down on every sheet of paper that you do with trig functions.